guys. So the next unit that we're going to talk about is sensation and perception. And I'm really bummed that we can't do this in school because I have so many really neat in-school experiments that we can do that we really can't do virtually. But I've tried to adapt a number of them so that you can do them at home. So sensation and perception are absolutely necessary in order to gather and interpret information regarding our surroundings. First thing we need to look at then is what's the difference between sensation and perception, because they are related, but they are not the same thing. So the first thing that we'll look at here is sensation. Sensation is what happens whenever a stimulus activates a receptor. It's a feeling. It's always the result of some type of physical stimuli. So what's a stimulus? It's any aspect or change to the environment to which an organism responds. The stimulation of senses is automatic. It's when you hear a sound, it's when you see something, it's when you feel something, it's when you smell something, it's when you taste something. On the other hand, perception is the organization of that sensory information into something meaningful. It's the interpretation, if you will, of that feeling. So perception, like sensation is the physical aspect of it. Perception is your mind making sense of what you've just felt, tasted, smelled, etc. And it can be the result of several sensations combined together. So let's say that I blindfold you, I take you outside, you feel moisture on your skin, and it's really warm out. Your past experience and those several sensations together, it's moist and it's warm, tell you like, oh, I must be experiencing rain. If I were to blindfold you and take you outside and you feel moisture on your skin and it's freezing outside, your past experiences and those several sensations together, wet and cold, lead you to the conclusion that it is snowing. So past experience plays a big role in how we perceive what it is that we are experiencing. Psychophysics is the study of the relationship between sensory experiences and the physical stimuli that cause them. Sensation and perception can't be taken apart from one another, really. Like, it's very much an interplay between the two. And the video that I have for you here will demonstrate that.
At any one moment, we are being bombarded by sensory information. Our brains do a remarkable job of making sense of it all. It seems easy enough to separate the sounds we hear from the sights we see. But there is one illusion that reveals this isn't always the case.
Ba, ba, ba.
Have a look at this. What do you hear?
Ba, ba, ba. Ba, ba, ba.
But look what happens when we change the picture.
Ba, ba, ba. Ba, ba, ba. Ba.
And yet, the sound hasn't changed. In every clip, you are only ever hearing ba with a B.
Ba, ba.
It's an illusion known as the McGurk effect.
Ba,
Take another look.
ba.
Concentrate first on the right of the screen.
Ba,
Now to the left of the screen.
ba.
The illusion occurs because what you are seeing clashes with what you are hearing.
In the illusion, what we see overrides what we hear. So the mouth movements we see as we look at a face can actually influence what we believe we're hearing. If we close our eyes, we actually hear the sound as it is. If we open our eyes, we actually see how the mouth movements can influence what we're hearing. Ba, ba, ba.
It's a bizarre effect. Remember, the only sound you're hearing is ba with a B.
Ba, 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 ba.
What's remarkable about this illusion is even knowing how it's done doesn't seem to make a difference.
Ba. The effect works no matter how much you know about the effect. I've been studying the McGurk effect for 25 years now, and I've been the face in the stimuli. I've seen stimuli thousands and thousands of times, but the effect still works on me. I can't help it. The speech brain just takes in that information and doesn't care about what outside knowledge you bring to.
Okay, So you can see from that there's an interplay between sensation and perception. What you see influences what you hear. When we talk about threshold, or when we talk about sensation and perception, we also have to talk about thresholds. And you have a couple different types of thresholds. The first type of threshold is your absolute threshold. The absolute threshold is the weakest amount of a stimulus that a person can detect 50% of the time. And we're talking about the average person here. Obviously, people have differences in terms of how good their eyesight happens to be. We're talking on average, what can someone detect 50% of the time? So as far as sight is concerned, believe it or not, the absolute threshold is being able to see a single candle flame from 30 miles away on a dark, clear night. For hearing, it's being able to hear a watch ticking from 20 feet away. For taste, it is being able to detect 1 teaspoon of sugar dissolved in 2 gallons of water. For smell, it's being able to detect 1 drop of perfume in a 3-room house. And for touch, it's being able to feel a bee's wing falling a distance of 1 centimeter onto your cheek. The absolute threshold for specific stimulus is obviously going to differ from person to person because of different physiological and biological differences. There would also be a difference if we were dropping the bee's wing on your cheek versus on your thigh. Like your cheek is a much more sensitive area than your thigh. So anyway, there's also the difference threshold. The difference threshold is the smallest change in a physical stimulus that can be detected half of the time. How much does it have to change in order for me to notice that a change has taken place? So the difference is, generally speaking, about 20%. And this comes back to something that's known as Weber's Law. Weber's Law states that the larger or stronger a stimulus, the larger the change required for a person to notice that anything has actually happened. The best way to do this is to give you an example. So you have 2 piles of rocks here. If I took 1 rock away from the pile on the left, you probably wouldn't notice it because there are a lot of rocks there. If, however, I took 1 rock away from the pile on the right, you would notice it because there's only a couple of rocks there. It's much like how if you have an empty book bag and you put a 2-pound book in it, you're going to notice that there was a difference between carrying the empty book bag versus carrying the book bag that now has a 2-pound book in it. If, however, you already had all of your books from your major subjects in your book bag and your book bag weighed, 70 pounds and you added another 2 pounds to that book bag, you would not notice the difference. So this is a principle that comes into play for anyone who is interested in like weight training and things like that. Like in order for your body to notice a difference, you have to, generally speaking, add about 20%. And that falls across the board as far as like light, hearing, etc. are concerned. If it's a dark room and I turn on 1 light bulb, I'll notice that there has been a change in the amount of light in the room. If I walk into a room that has 100 light bulbs already illuminated and I turn on 1 more light bulb, I'm not going to notice that the room's any brighter. I'm going to have to turn on about 20 more light bulbs in order to notice that the room has gotten brighter. Our senses also adapt. We adjust ourselves whenever there's a constant level of stimulation. We become more sensitive to weak stimuli and less sensitive to unchanging stimuli. So becoming more sensitive to weak stimuli. If you've ever walked into a movie theater a little bit late and at first you walk in and you kind of have to stop because you can't see anything. But within a couple seconds you start to adjust, and if you stand there for about a minute, you're able to make out, which seats are empty, if there's a Coke cup in the way of you getting to the seat, things like that. You also become less sensitive to things that are unchanging. That's what allows people to get used to living next to airports, railroad tracks, busy roads, etc. You stop hearing the noise because you hear it all the time. We are built to notice change. Why? Because change could potentially equal danger. So that's what we pay attention to more than anything, is that changing stimuli. Another important principle with sensation and perception is the signal detection theory. This is the idea that when we notice something, it's not just the strength of the stimuli that determines whether or not we pay attention. It's also elements like our setting, our physical state, our mood, and our attitude. We focus on what we think is important. That's why people can do things like read newspapers on a crowded, noisy bus, because they can tune all those other things out. The newspaper article itself becomes the most important thing, even though there are other stronger stimuli that are present. At the same time, we also have to keep into account the Stroop effect. Stroop effect states that we notice some things automatically in spite of distracting information. In other words, we can notice things, but sometimes it takes us more effort in which to do it. So there's a really fun little experiment here that you can do that demonstrates this. So what I want you to do is simply, to yourself, out loud, whatever, doesn't matter, I want you to read the color of the word, okay? So go ahead and take a couple seconds to do that. Okay, and on the 1 to 10 scale of difficulty, 10 being the hardest thing you've ever done in your life, 1 being the easiest thing you've ever done in your life, where did that rank? It's probably going to rank somewhere between a 1 or a 2, right? It's really not that hard to do. So now I'm going to ask you to do the same thing for the next slide. Again, I'm asking you to read the color of the word. So on the 1 to 10 scale, again, 10 being the hardest thing you've ever done in your life and 1 being the easiest thing you've ever done in your life, where did that one rank? Should have been a little bit more difficult. Why? Because the color of the word and the word itself do not match up. We can do the task, but first we notice the word that we're reading, not necessarily the color of the word. Okay. So when we get together next time, we'll take a look at the senses. There's actually 7 senses, not 5. And we'll start by taking a look at the 2 most studied senses, which are vision and hearing. And I'll have a little discussion board question for you to answer after you're done with this. Have a great day, guys.